Okay, one last implicit differentiation video. This one involves doing the second derivative. So here we go. If 3x to the fourth power plus 2y squared equals 6y, evaluate the second derivative when x equals -1, y equals +1. So we start like any other problem here and do the first derivative. So we have the power rule here. This is just going to be 12x cubed. And then when we take the derivative of y, we always have to state that we're doing it with respect to x because x is the independent variable. So this will be 4y to the first power dy dx. And then this one will just be, this is a 1 here, so 6 times 1, and then you end up with y to the 0 power, which is just 1. But you also have a dy dx here. Anytime you take the derivative of a variable that's not the independent variable, which remember the x variable is always independent when you're dealing with x's and y's. Anytime you're doing the derivative of the variable that's not the independent, you have to state that you're doing the derivative of that variable with respect to the independent variable. Okay, so we have 12x cubed, 4y to the first power. We did the derivative of a y, doing things with respect to x. And then we have 6 y to the 0 power doesn't need to be written there because it's a 1. And we did the derivative of a y again with respect to x. So I said in a different video that I'm a big fan of plugging numbers in when they give them to you, but we haven't done the second derivative yet. So we actually need to do the derivative again. Before you can do that, you need to solve and get the dy dx by itself. So we've got 3 terms here. There's this term, and then there's this term. And 2 of them have the dy dx. We need to do some rearranging. We got to cross over the equal sign, bring the dy dx's together, and that 12x cube's got to go to the other side. So I just moved, I don't know why, I could have just left the 12x cubed over here and brought this over, would have been less moving, but I brought the 6 this direction by subtracting, and I took the 12x cubed and I brought it this direction also by subtracting. It doesn't matter which side you choose. I guess we're just all particular to putting things on the left. And then once you have the dy dx terms all together on the same side, the next step is to factor out that common dy dx term. So you pull that out and you're just left with 4y minus 6. And then the reason you do that is to create that multiplication so you can divide. And now you have dy dx all by itself. Okay, so that's the expression for the first derivative. Second derivative is a little more icky because we have to use the quotient rule this time. This is a fraction. And I learned that by words also. I don't know if you saw the product rule video in the previous. I say the product rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. I use bottom and top. So we have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now, when we take the derivative of the top, it's not a big deal. It's the independent variable, so it's just the power rule. But when you do the derivative of the bottom, the 6 is a 0, but the 4y, we're taking the derivative of a y, and again, it's not the independent, so we have to state it's the derivative of the y variable with respect to the x, because x is the independent. Okay, let's clean this up a little bit. Like I said, I'm a huge fan, now that we have the equation or the expression for the second derivative, huge fan of plugging these numbers in right now. Like there's no point in going crazy and multiplying. Like I don't need to distribute this stuff. Why do that and risk making a mistake? Plug the numbers in now because you'll probably be able to get it to look simpler and make it look a little less crazy. I know that this is the 4 times the 1, going a little fast. Feel free to pause and, slow yourself down here. And you end up with this situation. Once it's all simplified, you're not done yet though, because we need to deal with this piece. We can't just leave that in there. We actually know what that equals. We were given that. Well, we found that ourselves actually. So we plug that back in. And again, x equals -1 and y equals 1 works for that as well. So plug those numbers in and simplify again. Again, take your time on this. I went through that very quickly. I don't expect you to follow that quickly. Pause and do the work yourself to make sure that you're getting the same thing.